Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. When you look up at the night sky, do you ever find yourself wondering if there is life from another planet staring back at you? At first glance, the galaxy provides the impression of being very desolate. Despite our best efforts, we have not discovered any signs of life. However, at this point in time, the search for life beyond Earth is just getting started. Some scientists today believe that life may have arisen independently in other areas of our solar system, such as the icy moon Europa of Jupiter or the shrouded moon Titan of Saturn. These are only two examples of the things that science has discovered. However, is it conceivable that there is another solar system out there where life has flourished, and that at some point in the future, it will be possible for humanity to travel to that system? An Earth-sized world that orbits Proxima Centauri, the star that is nearest to the Sun, is likely to be the planet in question. In fact, it is plausible that this planet is virtually next door. Despite the severe radiation bombardment that it receives from its star, this close planet may still have a great deal of potential as a location to find life that originates from another planet. When it comes to stars, Proxima Centauri is somewhat peculiar. Alpha Centauri A and B, the two major stars in the system, are around the same size as the Sun and orbit each other in a relatively close proximity. The system itself is made up of three stars. Proxima Centauri is a red dwarf star that has a low mass, a long lifespan, and a cold surface temperature. However, in order to make out this star, a powerful telescope is required. However, it is the closest of the three, with a distance of 4.2 light-years from the Sun. Furthermore, it is the host of 3 exoplanets, 2 of which have been confirmed, and 1 of which is located in the habitable zone of the star. The region known as Proxima B is the region in which the temperature would not be either too high or too low to permit the development of liquid hydrocarbons. As a result of its close proximity to its star and the fact that it is nearly as huge and heavy as Earth, which suggests that it is most likely a rocky world, its discovery in 2016 caused a great deal of excitement within the scientific community. Back then, people had hopes and speculations about a number of things, including an atmosphere similar to that of Earth, raw materials and components similar to those of Earth, and, most thrilling of all, the possibility of life being on the surface. After the completion of additional studies, it became clear that Proxima B is experiencing a trip that is significantly different from that of Earth, despite the fact that it shares many parallels with Earth. A major cooling impact is brought about by the fact that Proxima Centauri, a red dwarf star with a diameter of around 14% of that of the Sun, is very small. In spite of the fact that it is located in the habitable zone, Proxima B is more than 20 times closer to its star than the distance between Earth and Mars is. As a consequence of this, the length of a year on Proxima B is just 11.2 days on Earth. Contrary to what you may anticipate, a star that is smaller does not generally have a more tranquil atmosphere. Red dwarfs are able to produce highly intense solar flares at a rate that is significantly higher than that of the Sun. This is because their nuclear fusion cores are located in close proximity to their surfaces. As a consequence, the surface becomes substantially more disordered, which results in the production of extraordinarily intense magnetic fields. A cascade of powerful magnetic fields is produced as a consequence, which has the potential to unleash a deluge of high-energy radiation on the surrounding environment. Proxima B is likely being bombarded by space weather that is substantially more intense than what we experience on Earth. This is likely the case because of the incredibly close orbit that it is in. Proxima B is also likely to be tidally locked in a synchronous rotation. This is a very strong possibility. In a manner analogous to that of our own moon, this indicates that one side is always facing the star, while the other side is always facing away from the star. On the other hand, this would imply that half of the planet on Proxima B is always illuminated by the Sun, while the other half remains incarcerated in the darkness of night. In addition to the extraordinarily high radiation levels, there is a possibility that solar flares could be released on the side of the planet that is facing the Sun. In the year 2021, for example, a gigantic flare that was nearly 100 times more powerful than anything that has ever been observed in our solar system was observed erupting from the star Proxima Centauri. Several scholars have hypothesized that these powerful bursts may progressively deplete the water supply of the exoplanet by destroying its atmosphere, if that the exoplanet did in fact have an atmosphere. Therefore, despite the fact that it is located in the so-called habitable zone, it is possible that Proxima B is not highly livable because of the close orbit that it receives from its small star. Being able to survive radiation levels that are up to 500 times greater than those of Earth would require an atmosphere that is thicker than the atmosphere of Earth and a magnetic field that is stronger than the magnetic field of Earth. At first look, it would appear that planets that are subjected to this kind of temperature would become devoid of their atmospheres, their seas would evaporate, and their DNA would be burnt. In spite of the fact that it was previously believed that Proxima B was an uninhabitable world, current discoveries from Earth climate models indicate that rocky exoplanets that orbit red dwarfs are actually extremely habitable. Through the process of modeling the climate of a planet in 3 dimensions, scientists were able to gain a better understanding of the ways in which certain situations and changes influence the climates of other worlds. A supercomputer was responsible for making this a reality. Their models of the various climates on Proxima B suggest that the exoplanet may still be habitable despite the fact that it is tidally locked and that one side of it is exposed to huge levels of radiation. Given that it has an atmosphere that is comparable to that of the current Earth and a strong magnetic field that shields it from the extreme radiation that it is subjected to, it is possible that Proxima B has an ocean that covers the night side of the planet. When viewed from the perspective of a spaceship, it might look like a massive eyeball looking into its own star. While lowering the freezing point of the water and allowing it to grow into colder regions, the amount of salt that is present in the water is the primary factor that controls how much of the Earth it covers. Despite the presence of high salinity, dense atmospheres, and strong magnetic fields, these simulations suggest that the formation of an ocean is still possible in certain settings. If certain conditions are satisfied, Proxima B has the potential to be a viable environment for life. As an illustration, bacteria have been able to survive in the Dead Sea on Earth, which has a salt level that is greater than 30%. Hence, it is not completely out of the possibility that Proxima B could contain life that is dependent on that substance. Furthermore, the simulation demonstrated that dense clouds on the side of the stars had the ability to function as a massive canopy. This has the potential to further mitigate the ionizing radiation from the star, and when combined with ocean and atmospheric circulation, it could make it possible for heated air to move around the planet. This would transfer heat to the cold side of the planet, preventing the atmosphere from freezing and forming regions that retain liquid water despite never seeing light. The findings of this study, despite the fact that they are fascinating, do not provide any information regarding the atmosphere of Proxima B or its water history. However, the fact that water is still present on the exoplanet may be a result of the fact that it was formed in a very wet environment. There is a possibility that it was located at a considerable distance from its red dwarf star in its early days. Nevertheless, when it drew closer, it became a shield against powerful flares. Despite the fact that the environment on Proxima B are expected to be very different from those on Earth, it is possible that extraterrestrial life exists beneath the strange skies of Proxima B. They were able to see icy wastelands, rugged mountains, barren deserts, and oceans that stretched out into the horizon. All of these things were within their field of view. Time is the only thing that might reveal the odd and wonderful forms that life might take if it is actually possible for life to exist under the searing light of its red dwarf star. There could be a great number of other planets in the galaxy that are habitable, similar to Proxima B, assuming this one is an example. Stars that are classified as red dwarfs constitute the great bulk of the stellar population in the Milky Way. The scientific community has reached an agreement that 20 of the 30 stars that make up our solar system are classified as red dwarfs. Taking this into consideration, it is possible that extraterrestrial life on planets orbiting these relatively commonplace stars is the norm, and that humans are the guests who are genuinely out of the ordinary. On the other hand, there is a great deal of speculation over Proxima B due to the fact that no direct photos of the elusive exoplanet have ever been taken, and our understanding of it is limited. The use of large telescopes, on the other hand, will make it possible for us to finally get a glimpse of this fascinating planet. It has been suggested that tiny groups of probes that are propelled by laser beams should be sent to the Proxima Centauri system. The James Webb Space Telescope has the potential to find an atmosphere on this system. It is possible that one of these missions will arrive at the system by the year 2075. In order to complete this journey, humans would have to board on a spacecraft that would take thousands of years to complete. A brand new ground-based device known as the Giant Magellan Telescope is nonetheless the approach that is most expected for the possibility of observing Proxima B in the not-too-distant future. According to what is claimed on the official website of this groundbreaking equipment, it will be among the most powerful instruments that have ever been built on Earth. Its resolution is 4 times higher than that of the James Webb Telescope. Despite the fact that it is still in its preliminary stages of development, it is anticipated that it will be illuminated for the first time in the year 2029. The scientists are looking forward to finally being able to observe Proxima B once it is operational. They may even be able to capture a short video of the planet as it revolves its star and analyze spectra in order to discover biosignatures in its atmosphere. What appears to be a promising future for our nearest extraterrestrial friend is that things are looking up. Within the next few years, it is possible that we may know the answer, putting an end to the speculation around whether or not Proxima B is a planet that sustains life or merely a lifeless rock that we ought to move on from. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.